Everyone. As promised, I'm going to make a priority queue series about all those classical problems. Today we're going to look at the top k frequent words. The problem statement is pretty straightforward. We're given an array of words and we need to count the frequency of each of them, and we output the top k frequent words. So we need to count words with this frequency, and we need to output the top k frequent words. For the counting words and frequency, we can use data structure. We can use a hash map to store the words and its frequency. It's pretty straightforward. We just do a linear scan, and the time complexity will be O(n). For this one, and the space complexity will also be O(n) for data structures. To output the k frequent words, normally if we say k frequent, k most frequent, or k least frequent, then a priority queue might be the way to go, since it can access and maintain a size of k of the most or least container. So we can use a priority queue with this pair node, where node is including both its frequency as well as the word. Why we do this is because actually we can just do word and frequency, because we are going to customize our comparator function anyways, since he said if the frequency, we first should consider frequency sorted by frequency from the highest to lowest. Otherwise, the word with the lower alphabetic order actually should come first. So this is how we should define our customized comparator function. The whole process should take O(n log k) time, and the space is still just linear. Okay, cool. And the last step is to output the element from the heap, from the main heap, and reverse our answer, which again takes another linear time. Within that, let's look at the implementation. So step 1 is to create a hash map. In C++, it's called unordered map. We specify its key as string to present the word and the frequency. Then I just loop through all the words, and I add each word one by one. So after we have the hash map, we need to create a priority queue container to when we iterate through this map, we just push this to our priority queue. Step 2, create a priority queue and maintain it. So we would have a priority queue. So the element in this container should be a node, and it should have both the word information as well as the frequency information. So we can have the word as a string and an int. So it should have both the word information as well as the frequency information. So let's define our comparator. We have two ways to define our comparator. For this one, I'm just going to define as a struct. We can also use lambda function. So struct comparator, we just override this Boolean comparator. The input would still be a pair of A and a pair of B. So we should first consider its frequency. So we should return A.second, which is the frequency. For a min heap, it's actually bigger than B.second. Or if the frequency are equal, we should return A is smaller than B. We should compare the strings. Okay, cool. After we have our container, we can loop through our hash map in M, and we just push our hash map. Actually, we can directly push this pair because it's word and frequency, which is the same as the definition from the hash map. And if my pq.size is more than k, then I just pop the lowest frequency one. So in my container, it's always the top frequent words. Pop it. Okay, so afterwards, I have a container that has k words. The last one is I just need to output my string from my project queue. Let me declare a container answer, and I will just return this answer. Since we always pop the lowest, actually when we deal with this, we should reverse our answer before we output the results. And answer end. And while my project queue is not equal to empty, I can push back the top element, and it should be the first string. Then I just need to pop pq.pop. Cool. Yeah. So this is a very classical application of priority queue to count top k, the most k, biggest k, smallest k problem. Let's try test the cases and submit it. Okay, I think, yeah, this is a typo that I often make, so I should make a conscious effort to not make this mistake again. Cool. Seems it passed. Actually, there's one line we can also